So I like to say that I don't memorize the temperature conversion equations. I derive them every time, but that's not so important. I know that for water, one point of interest is that 100 degrees Celsius is equivalent to 212 degrees Fahrenheit, basically. And then the other point of interest, so here's water's boiling point, water's freezing point, is 0 degrees Celsius is equivalent to 32 degrees Fahrenheit. Okay, so that's very nice. If you wanted to derive these, it's very simple actually. The magic number is 1.8 or 9/5, and then it flips to 5/9 and then 32. So you say here, you say, oh, well, Fahrenheit is 32 degrees higher. That means it must have been added in. Added into what? Well, 9/5 of something. 1.8 times 100 is 180 plus 32 degrees. So you end up with the temperature conversion formulae that are very easy to find anywhere online. Okay. All right, so I won't make you derive these. Also, a little note, make sure that you are practicing Kelvin conversions, adding the 273 in. Also, I want to talk to you about unit conversion. So let me clear this. Unit conversion is extremely important, and I really don't need to go into a lecture on that. But what I call dimensional analysis is what most people call unit conversion. Dimensional analysis basically allows you to get from one side of from one known to an unknown very easily. So I've used dimensional analysis for a long, long time. And I always tell my students, if you know the units that you're trying to get an answer into, you probably can just manipulate units. And in many typical questions, you don't even have to know a formula. As long as you know how to get from one unit to another, you can usually find the right answer. It's very interesting how that works out. So with dimensional analysis, I'm going to give you a completely contrived example. Let's say that we have water droplets. Water today is going to be green. It's like Secret of the Ooze. Okay. All right, and so we're forming a puddle. Maybe we're going to say it's going to fill a bin. How about that? Okay, water droplets from some unknown source. And I say, completely contrived, we start off with 26 kilograms, and it's going to drip at a rate of 26 kilograms complete per day. Now we're going to assume that this is pure water. Okay, pure H2O. Isn't that nice? All right, I didn't say I was an artist. And we want to convert that into milliliters of water per day. All right, so you might not know how to tackle this, so let's set it up. This is a skeleton. This is a dividing line, and these are just basically multiplying lines. It's often done like this. You put some fraction in parentheses. You have, X on top and Y on the bottom. I don't know. X2 on top and Y2 on the bottom, et cetera, et cetera, et cetera, equals. It's exactly the same thing, except it's much faster to do. So whichever way you've learned it, go for it. So we put our known here, 26 kilograms in the numerator, and then 1 day in the denominator. And then we're just like, oh, geez, where are we trying to get to? Well, I wanted milliliters per hour, actually. Okay, yeah, let's see. Bet you I can do that. Okay. Milliliters per hour. All right, so I want to get days to hours, so that's pretty easy. I know that for every 1 day, I have 24 hours approximately, right? That's my definition. 24 hours actually fully in a day. So why did LaFazia put it on top and the bottom was like chess, right? You can only go diagonally if you're a pawn. Really, the reason is that this is the numerator and this is the denominator, see? So I have things that are the same in the numerator and denominator, day over day cancels out. So now I'm left with kilograms per hour. Well, that's great because I know that I wanted to get milliliters per hour. So I'm already getting part of the equation. My hour is done. Check mark. Okay. So now you say, well, LaFazia, hold on, I got you in a little trap here. These are kilograms, and that's mass, and you're trying to get into milliliters, which is volume. Isn't that apples and oranges? Normally it would be, except I've got this funny little thing here called water. And I know that if this is pure water, I have an equivalency that 1 gram of water, that mass of water, will have a volume of 1 milliliter. And I'm just putting H2O down the bottom just to emphasize. And I'm just changing colors because it'll help keep things differentiated in your mind here. All right, so the hours are good. Kilograms, well, I need to get from kilograms to grams. Well, I know that for every 1 kilogram, kilo is 1,000, I have 1,000 grams, okay? Kilograms are gone. I don't want grams per hour, I want milliliters per hour. Well, I got to use my little conversion here, see? Here comes the conversion. For every 1 gram, I have 1 milliliter. Doesn't do anything to my number. 1 over 1 doesn't mean anything, right? Grams are gone, grams are gone. But I now have units of milliliters per hour. This is a much longer dimensional analysis problem than you might see in most cases, especially as you're starting out. But it is important to give you something to go back and digest. Remember, the cool thing about videos is that you can pause and you can listen to me over and over and over and over again. Isn't that great? All right, so what does all this really mean? I can take 26 times 1 times 1,000 times 1. Okay. And then it's 1 times 24 times 1 times 1. And I know. You're like, well, LaFazia, that's really 26 times 1,000 over 24. Well, sure it is. Absolutely. You could completely have avoided the ones. Okay. Let's see. You can do so many fun things here. Let's see. Divide by 2. That's an easy one, right? I know they're divisible by 2. 13. And let's see. I can even do a little further now. If you don't like this, then you can fast forward. I'd like to show you little fun math tricks. Divide 1,000 by 2 is 500. Divide 12 by 2 is 6. I can do it again. You could plug it into the calculator, folks, but I might as well have a little fun with it. All right, I know that these are both divisible by 2. That's 250. Gives me 3. 13's prime. I'm not going to get too far with that. I don't see 3 going into 250 too soon. So we'll see if we get anywhere. So I end up with, let's see. 13,250 over 3. A little fancy dancy calculating. You guys can do this yourselves. You could have done it from the beginning. You get the same answer. All right. You end up with 1,083.333 repeating. And this is in milliliters per hour. Now I'm going to take advantage of this opportunity to point out something else to you. We look at sig figs here, right? Look at sig figs of what we originally had, 26 kilograms. I could get really particular and say, well, we only had 1 here. I guess I could pretend there was a 0 there or a decimal there, 2 there. I'm going to go with these 2, right? I have to technically go with that. So technically, this would be what I would call approximately, can you take a guess? 2 sig figs? 1,100 milliliters per hour. All right, well, you can go back and look at that masterpiece some other time.